Okay, so as we've seen the past couple days, functions can be approximated using Taylor polynomials. E to the x, what? Yes, okay, you don't need to write this down because you already know it, right? Okay, if we approximated e to the x, because I messed up on the board.
I feel like we talked about this already.
We did. Okay, so the third degree polynomial that would approximate e to the x is up here. Okay, now, the more terms we have, the better our approximation, yes? Okay.
Yeah.
So, yeah, our goal is to get to infinitely many terms to approximate our non-polynomial function, okay? So we're going to work with what's called a power series, okay? It's an infinite series that we're going to use to approximate, eventually, non-polynomial functions, either centered at 0 or centered at a.
When we did integrals, because we learned trapezoids and all that stuff.
Yeah.
And then we learned the summations, and then we brought them together. That's what that reminds me of.
So we still have to do the work that we were doing on Tuesday, Wednesday, that was a Wednesday. We still have to do that work in order to write the power series, and that's really what we're going to work on after our quiz. So we'll take a quiz on Wednesday, and then we'll work on Taylor series, okay? But right now we're just going to work on power series, okay? Something that we'll talk about next week, okay? If we go back up here, I bet you can determine the pattern, right? What's going to be our next term? X to the 4th over 4 factorial and x to the 5th over 5 factorial. So eventually we're going to know that e to the x is the sum from n equals 0 to infinity of x to the n over n factorial. Okay? That's something that we're going to know and not have to even come up with it. Okay? But our main concern today is to take a power series and talk about its convergence, okay? Where, specifically, on what interval is it going to converge? So every series can do one of three things. It could converge at a single point. Boring. We would say the radius of convergence here is 0 because it only converges at a single point. Okay? Or it could converge on an interval. Now, the interval that I show you isn't the only thing that could happen because it could converge at one or both or none of the endpoints. Right now they're parentheses, but either one of those parentheses could be brackets depending, and that's something we're going to have to check for. So we could have a radius of convergence that gives us an interval. I wouldn't say that you have to write all this down. You could just say it converges on an interval. Okay? We're going to eventually talk about R. R is going to be our radius of convergence, but we will get there. It is also possible for our series to converge everywhere. And that's what we're going to figure out today. Which series do we want?
What?
I was just looking at his bag and if it was just candy or.
Yeah, where'd you get the bag from?
Oh, no, my mom gave it to me. Valentine's Day hadn't even started yet, and my mom already got back for me.
So her and I were the same today. Are you tired?
Yes,
Okay.
I was.
Just making sure nobody broke your heart today.
Oh, no.
Okay, so R is what we're going to call the radius of convergence. Okay? Whether I ask you to find a radius or an interval of convergence, you have to know what the radius is. So how far from the center will this power series still converge? Okay. Now, I don't feel like you have to draw all these pictures. I don't feel like that's necessary. But these are the things that can happen. So we just talked about these intervals. But then if we have a radius of convergence that is not 0 and not infinity, then our interval could be any of these 4, where the endpoints don't converge, one of the endpoints converge, both endpoints converge. And I know that that doesn't really make sense right now. We need to first work on what the heck is a radius of convergence, okay? And we're going to get there. But here's our center. We are going to find what's called a radius of convergence. That's how far from the center our power series still makes sense, or it still converges. And then we'll determine if the endpoints make it converge as well. Now, something that you definitely need to write down. If the power series only converges at C, the radius of convergence is 0. If we only converge at the center, our radius of convergence is 0. And if the series converges for all values, then your radius of convergence is infinity.
Everyone having a good day today.
Valentine's Day. Yeah.
I like how we say it's a holiday instead of describing it as Valentine's Day.
I will say that since Valentine's Day is falling on a Friday, I can definitely tell people are a little bit more wired today. Like there's a lot of hyper.
Really?
Oh yeah.
In our English class,
It was
Chris
really-
said that we were all dead and everybody looked like they were asleep.
Yeah, but it's second.
Well, it wasn't like that first hour.
I've seen some
Like-
people
Carrying around stuffed
My
animals.
first hour was pretty calm.
Yeah.
I hate that.
I'm in a first hour by myself, but that's not.
I'm like,
Hearing that, like,
save that for some.
Like lots of giggles, lots of.
I
Okay,
hate this
now you may be wondering, Mrs. Holman, how will we find the radius of convergence?
That's what series does. Exactly what I was
We are going to use the ratio test.
I feel like I've seen this somewhere before.
Yeah, it's the good one.
I told you the ratio test was gonna come in handy later.
I like that test.
Well, good, because you're gonna get sick of it.
This
I will not.
Well, what if I'm already sick of it? Will I learn to love it?
Yep.
Oh,
Okay, so write down this example, please.
ratio test. That's what I'm talking about. X dot.
Okay. Before we begin, number 1, where is this centered at?
0.
It's centered at 0. Whatever's raised to the nth power, we have just x to the n. There's no like x minus 4 to the n. I mean, I know there's a 2 multiplied to it, but there's nothing added or subtracted, so it's just centered at 0. Second of all, when we do the ratio test, in order for it to be convergent, we want our limit to be
Mathematical.
Less than one.
less than 1. We have a winner.
So can it be any number that's less than 0?
Yep.
So like -3.
Is the absolute value, what is the one or just?
Well, it's an absolute value,
It's the absolute
so
value.
Yeah, we're on the, I'm gonna be your fan spot.
so the limit as n approaches infinity of
I'm gonna pull up those games. What's that?
a sub n plus 1
Like these little, like really, really young.
divided by a sub n.
You gotta keep those big old ends.
Also, I did hear Tito was doing a buy one get one today.
This isn't gonna be
Who's doing that?
You did one.
I want to get one more. Burrito.
What do you
Scuba.
think?
I think it's gonna be like a couple. But
Okay,
it's just gonna be
so-
two.
I'm gonna go ahead. Well, first of all, the absolute value isn't really gonna affect anything. Do you agree? Okay. So we have n squared over n plus 1, the quantity squared. If I were to group my 2x to the powers together, what is going to be left?
2x in the new.
But I still need, you know what? I'm sorry, I lied. We still need. I'm sorry.
I feel kind of like you.
Because I kind of forgot about how we're left with an x. Okay, so the absolute values are still there. Now, what is the limit as n goes to infinity of this guy right here?
One.
This goes to 1. So we are left with the absolute value of 2x. And the absolute value of 2x needs to be less than 1.
It's not.
What?
It's not.
It can't be.
I don't understand.
But
It's
both sides-
infinity there.
So the absolute value of x is less than 1/2, which means our radius of convergence is 1/2.
Not
Wait a
including the
second. You took the limit of half of the limit. You didn't do the 2x. The limit of
Okay,
infinity.
what's the limit as
How does
n
n affect x
approaches
in a
infinity
limit?
of 2x?
Wait, why is there? Wait, okay. That makes a lot more sense.
Okay.
Might as well do something.
But we don't have to be
That's
like
better.
upset about it.
I don't think
It is okay that we didn't notice that n and x were different right now. We haven't seen that before. Okay? You are always, when you are doing the ratio test to test for the radius of convergence, you will always have an x
Does that mean you can go to the right 1/2 and the left 1/2? Yes.
from 0 and your,
above 1/2? And
no, just
below?
right now. We're on a number line.
Okay.
Okay, so that means that, like, if I were to plug in 1/4 for x, that series would be convergent. If I were to plug in negative 1/4 for x, that series would be convergent.
But anything else?
Anything outside of the 1/2. Okay? And we'll talk about the 1/2 specifically, but right now I just want to focus on radius of convergence. Okay? All right, let's look at another one. I'm going to change it slightly.
Slightly, it's not like a lot or no.
Tell me.
I don't.
Just write it down.
It's like less than greatly, but more than one at all.
Do you ever say something and then just have no clue why you said it?
Yeah, all the time.
No way.
That's kind of me right now. Everything.
No way. Really?
Everything okay back there, boys?
Yes.
Everything's perfectly fine.
Okay.
Richard's flaming me for some reason. No.
All right, so if I need to figure out the radius of convergence, we need to do the ratio test. So we have 2x to the, please be careful, when I plug in n plus 1, what does that exponent become?
2n plus
plus
2.
Whew,
Hey, we should start a band. We harmonize pretty well. You're gonna be left with 2n plus 2.
Hold on. Don't get ahead of everybody. Let's write it down.
I haven't even written it down.
Well, do that first.
Now, you should get to the test.
Alright.
Okay. So what's going to happen? First of all, let's talk about simplifying this right here. Okay. 2n plus 2 factorial would be 2n plus 2 times 2n plus 1 times 2n factorial. So those are all going to cancel out. Okay. Then, with the 2x to the powers, we're left with 2x the quantity squared. Okay. What is this limit?
Wait, does that mean for all?
Our limit is 0. Please tell me this.
Let's just see.
How often is 0 less than 1?
Most of the time?
Wait, what? Oh, so it's all of them?
Our radius of convergence is infinity. Any number that you plug in there, you will have a convergent.
Ah.
I feel like asking when the 0 is less.
So if you got negative
infinity, their accidents happen.
Ooh,
They're still
sorry.
70%.
Were you asking a question, Zane?
No.
Okay. Okay, so now what I want to do is I want to go back to this, and I want to actually talk about the interval of convergence. Okay? Where did we say this one was centered at? Okay. We are centered at 0. So our interval would be negative 1/2 to 1/2. What we need to decide is if those endpoints will give us a convergent series or not. Yes.
They will not.
Interesting that you say that.
You're wrong.
You're wrong.
Because it's a less than, not less than or equal to.
So you can make a fucking
Oh crap. Uh-oh.
Okay. I agree. It's less than 1. But what happens when the ratio test equals 1?
It's inconclusive.
It's inconclusive, which is why we have to test them.
Test
So, if x equals negative 1/2, then our series is n equals 0 to infinity of what's 2 times negative 1/2?
So negative 1.
So we have negative 1 to the 2n over, sorry, not 2n. This one didn't have the 2n. This one was just to the n, right?
Yeah, you get here.
Over n squared.
So it's P series.
Try again.
Still P series.
Try again.
Because you're
Alternating
comparing
series
to
to
P series.
It's absolutely.
So
It is an alternating series that converges,
Absolutely.
so we can put brackets at negative 1/2.
That makes me upset as spaghetti.
Why are you upset about that? You're really not.
Because you're wrong.
Okay,
Yeah, that was wrong.
now, we just went through like 2 weeks of you showing me all of your work with these tests. When we're testing the endpoints of an interval, if you just tell me what you used with a check mark, I'm going to be pretty good.
Cool.
Okay? Now, what happens if we plug in 1/2? We have 1 to the n over n squared. People, what's 1 to the n?
1.
That is 1. So this really
It's now a P series.
is 1 over n squared.
You were just
A p series that does what?
It converges converges.
Yeah, that's an.
It converges.
T series check mark.
Wait,
P is greater than
I
what?
thought 1 to the infinity was an indeterminate form.
Oh, snap.
What?
1 to the
Kidding.
infinity, I thought it was an indeterminate form.
We've been doing T series for a while now.
Linear to the infinity and all of those other forms that
One.
we love to use.
We're not plugging in infinity.
I'm thinking about. I understand what you're asking me. I'm sorry. I wasn't. Okay. Chris, up here.
Present.
Let's think about the sequence. 1 to the 1, 1 to the 2, 1 to the 3, 1 to the 4, 1 to the 5, 1 to the 6, 1 to the 7.
It gets
What's
bigger
happening?
and gets
1,
closer to
1,
0.
1, 1, 1, 1, 1. So we can put that on.
Okay.
Whew. Okay.
But we can't do that if it's not a series. Like, if we just ended up with like
A straight line.
Now,
There we go.
when we have a radius of infinity, and I ask you for the interval,
Oh.
you would give me all real numbers.
Yes.
so is that true for all times that are equals
Yep.
infinity?
So, if
So when are we going to get a radius of convergence of infinity? When your ratio test gives you a number,
Number.
more than likely 0, it's really always 0, and that's less than 1.
but so
Okay.
it can't be negative infinity because it's technically always less than
It's an absolute value.
Yeah.
It's going the other way.
It's an absolute value.
Well, your
Also,
radius
it
is
changed to
infinity, so
infinity,
it's
and then it would
both
have to be
sides.
0.
Okay. All right, let's make this interesting. Write it down.
That's 0 minus whatever. I'm not.
So
It's whatever.
Just write it down. We feel like we need to always add in our 2 cents. Just write it down. And if everyone adds in their 2 cents, then it gets really loud in here.
It's to be like
And I only have 22 cents, and that's not very much. There's 11 people.
I just. Okay,
Just stop. Nope, nope, nope,
I'm
nope.
just confused.
On this problem?
No,
On the problem before?
kinda.
What's wrong?
Because, so when you're doing sequences in series, do you just not worry about indeterminate forms?
Are we taking a limit?
That's limited and approaches infinity.
Well, again, we got 0.
But then the interval's to infinity, so if you had x equaling infinity, that's 0 times infinity.
Okay, you wouldn't have x equaling infinity. X has to be a real number. But what this is saying is that any real number works when you plug it into x. Yes? Okay.
There.
All right. Richard, where is this centered at?
5.
This is centered at 5. We have x minus 5 to the a. Okay? So task number 1, we need to find our our radius of convergence. Set up your ratio test. You don't need me for that. Okay. Now, that negative 1 to the powers, we're inside an absolute value. It doesn't matter, right? Those are not going to affect anything. So I'm going to stop writing them because we're inside an absolute value. Okay? All right. So let's group some things together. First of all, I have an n over n plus 1. All right. I have a 5 to the n over 5 to the n plus 1. That would be a 1/5.
Yes.
And then we have an x minus 5 to the n plus 1 over an x minus 5. So we're left over x minus 5. Okay. Now, Caleb, what's this limit? That limit's 1. So we have the absolute value of x minus 5 over 5, and we need that to be less than 1.
I thought if you had an absolute value with like an inequality like equation, you had to do something weird with like negative and positive, like you
Yep.
had 2 answers.
So we're going to keep it like this. I am not going to do anything with that 5 here because we're centered at 5. So I'm going to keep this as x minus 5. So wherever you're centered at, you want that to end up right here. If you're centered at 3, this needs to be x minus 3. If you're centered at 15, this needs to be x minus 15. Okay? What's our radius of convergence?
5.
Okay? Our radius of convergence is 5. This means we're centered at 5. And like I said, we need to end up with x minus c right here. All the other numbers go over the other side. Okay, so we don't really have to worry about like that inequality thing that you were talking about. Let's just think about if our radius of convergence is 5 and we're centered at 5, what's our interval? 0 to 10.
Yep.
All right. We just need to decide if 0 and or 10 make this series converge. Nope, it was a like this is gonna be intense. You ready?
I think you mean fun.
X equals 0 means we have the series of negative 1 to the n plus 1. What's 0 minus 5?
Negative 5. Yep. You can't do that. We're just not going to do all
Hold on. We're gonna be fine. Do you see how we're so close to having 5 to the n over 5 to n they can cancel?
That's just part of it.
Okay, we can write, hold on. We can write negative 5 to the n as negative 1 to the n times 5 to the n. That is mathematically legal. And then those can cancel out.
So then it would be divergent.
Hold on. Negative 1 would have what power? N plus 1 plus n, because when we multiply, we would add our exponents. So this is 2n plus 1.
I don't like it.
Okay. Tell me what kind of numbers we get out of 2n plus 1?
Even odd. No, only odd.
Only odd. So is this alternating?
No.
No.
It is just negative 1 over n.
It feels like something I would get.
Can't do it.
Yeah, you do it.
So this is a p series
Divergence.
that diverges.
And it's greater than or less than 1.
So we don't include 0 in our interval.
Wait, so can you do P series if there's like a number other than 1 on top?
Yeah, because we can just take it out.
So I had to do it for
And
10
then
as
the P
well.
series works.
Mhm.
Even though there's other stuff.
What? It's just 1 over n.
But what if it was like 5 or something?
You can
We can take it out. A constant we can pull out.
Oh, I mean like a 5n or something.
Then we would have to do a limit comparison test. And that's easy to think about too.
I guess I get it, yeah.
Okay. So now x equals 10 is going to have a, I mean, I don't know what it's going to end up with, but we're going to have a similar thing happen because what is 10 minus 5? Right? If we put 10 in for x, 10 minus 5 is 5. So that becomes 5 to the n. And those cancel. So we're okay. Is there a question or you have a statement?
Does it matter if it conditionally or absolutely converges?
Nope.
No.
Nope. Just that it converges. So then this is negative 1 to the n plus 1 over n.
Yeah.
This is an alternating series.
Still diverges.
Why?
No.
It converges.
Oh.
AST check mark.
So we get to include him. Okay? The convergence tests is not the difficult part of this. The algebra simplifying to be able to use a test is what you're going to need to be very careful with.
Can we not write the actual stuff on the sigma too?
I'm going to be
Can we do that?
pretty flexible about that.
Because that's a lot of complicated.
You're right. You're right.
This must be why they say the hardest part.
Easy.
He's not wrong. What are you watching?
Anthony's calculus TikToks. They're
Why are
good.
you watching them now?
Because they hadn't seen it.
I want to see it.
God story.
This one, wouldn't you want to see
They're pretty good.
his math TikToks?
What do they?
I would like you to write this down.
Was it the one you put on the story?
Yeah.
Oh
He
my
showed
God.
me one already.
Did you show her that one? Yeah. No, it's
Okay, do you notice anything familiar?
Talking about the TikTok
Oh, yeah, I'm confused.
Yes, I'm sure she's
This
talking about
the series we're using.
Yes. Have
Same as
we?
the first example.
Okay, this series is the same as the first example.
Really?
Yep.
Yeah.
My brain
Yeah.
remembers things.
So if I call this f of
Write
x,
it down.
if I call this f of x, f prime of x would be how do we take a derivative?
Quotient rule.
Well, with respect to x.
So it's just 2?
So 2x is to the n, so power rule
Wait, hold on. I thought you said-
times chain rule.
Well, why don't you have to do the bottom then if you're doing the n on the top?
It's a coefficient. Oh.
So this is in terms of x.
So shouldn't you only
So
do the derivative
any of
that?
the n's are like constants right now because we're taking the derivative with respect to x.
Okay.
So only the x is what we care about. All of the numbers and n's we treat as constants. So since x was raised to a power, we did the power rule, but then we had to do the chain rule times 2 because 2 was
Oh, I
inside.
get it. Okay.
Okay? Now, when we take the derivative, we do need to adjust this guy.
Why is it
There's a lot of
two?
going on here.
Why'd you just add 1 to the n?
What?
You made it n equals 2.
Mhm.
Like, why?
Actually, in this one, I think we can keep it as 1 here. However, if your original series was n equals 0, when you do the derivative, you have to adjust it to n equals 1 because of this right here. Okay? So in this one, we're okay. But if this were to begin at 0, we would have to change this one to 1. Now, what is cool about this is that we do not have to do the ratio test again. Whether it's the function, its derivative, or its antiderivative, the radius of convergence will remain the same. The endpoints you would have to re-figure out, but the radius itself would stay the same.
Yeah, I'm forgetting it maybe.
What am I forgetting?
No, I-
Okay. Okay. Now, before you do any work, can we simplify that?
You could take an n out.
Yes.
This is 2x to the n minus 1 times 2 over n. This is the n squared. N. Okay, so then we could retest our endpoints with that one. Okay, let's think about the antiderivative very quickly. Can we do that? We have some time. If I erase this, we'll mess you up. Can I erase it? Okay, well, I saw people writing. Wasn't sure. The antiderivative. Okay. N squared is just a constant, but let's think about what we do with the power rule when we take the antiderivative. What do? We add and divide by it. And then since we have 2 in there, we'll have to counteract that with a 2 in the bottom. What's its radius of convergence? 1/2, because it's the same as the function. You would just have to recheck the endpoints. Okay. Would you like to take either one of those and check the endpoints for them? Like you can, let's pick one together. You want to do this one?
Yeah, I already on this.
Okay.
Yes.
That's true.
So if x equals -1/2,
Sorry. Days off.
what's 2 times -1/2?
Negative one.
Okay.
Have to register the question
Well, that was nice. I didn't have to do a lot of rearranging. It's an alternating series. And is it going to be, does it have a limit of 0 and is it decreasing?
Oh yeah.
Oh, yeah. Okay. What's 2 times 1/2?
One.
And 1 to the n plus 1?
Is one.
But now
Derivative
now-
test.
Oh,
Integral test.
We could do the limit comparison test with 1 over n cubed, and it would work.
Couldn't you just do the direct comparison as well? 1 over n cubed is all of it.
you worked today. Number,
1 over n cubed.
oh yeah, it's last line 6.
So this is always different.
So that's the last line.
Sorry, I had to process that.
Yay.
Okay, you have a book assignment. Okay. I believe the first questions will be radius of convergence, then it'll go into interval of convergence. Please make sure you test your endpoints. Okay.